Selamat sejahtera and hi everyone. My name is Ying. For this assignment, we need to pick a structure or building around OPSI that makes the geometrical shapes and concept we have learned in the class. We choose Surau An-Nur as our building of investigation, which located around OPSI and features various geometrical shapes. Surau An-Nur was fully completed in June 1922 and was built simultaneously with the Surau An-Nur building, which began in August 1919. Castavan, a well-known architect from the Federated Malay State, designed this structure. Besides that, this surau, also known as Surau Pak Asli during MPSI era. It is named after the photographer who worked at MPSI in 1918 and was considered persistent in maintaining this surau. This surau is now managed by OPSI Islamic Center after being renovated, freshly painted, and outfitted with a modern sound system. At one time, this surau can hold up to 100 pagans. Selamat sejahtera and hi everyone. Now, I want to describe the location of Surau An-Nur. Surau An-Nur is located within Sultan Abdul Jalil Shah campus, KSAJS of Sultan Idris Education University, UPSI. Sultan Abdul Jalil Shah campus, known as the old campus of UPSI, is an important part of university history and has historical value. We can see that Surau An-Nur is next to the gymnasium, and across the street is bangunan SKTM and tennis court.
Hi, so the usage of the building that we have chosen is for the Muslim to perform their 5 daily prayers, where students or the academic staff can perform their daily prayers at here. Hi, Assalamualaikum and good day. My name is Muhammad and today I'm going to the size measure of the structure we investigate at the Surau An-Nur. First thing first, let's go to the triangle prism.
With the side of the bases are of length 330 cm, 62 cm, and 335.77 cm, while the length of altitude is 43 cm.
Okay, the next structure that we have investigated at this Surau An-Nur building is the window itself, which consists of 2 polygon shapes. The first one is the square at the bottom, and at the top is a semicircle. Let's talk about the semicircle first, where its diameter is 121 cm, while the radius itself is 60.5 cm. Now let's talk about the square polygon, where the length or the measure of the sides is 121 cm, and the motif itself is measure of 108 cm, and from this point to this point is 33 cm. The third structure that we have investigated is the face of the Surau An-Nur, where as you can see here, it consists of hexagonal polygon, where the sides here of the environment is 20 cm, while from this point is 10 cm itself.
Next, I will be presenting the geometrical shapes that exist in the Surau An-Nur building. One of the sides in Surau An-Nur building consists a lot of geometrical shapes such as square, rectangle, semicircle, hexagon, right angle triangle, and right triangle prism. Each of geometrical shapes has its own perimeter, diameter, diagonal, angle, symmetry, length, width, and volume. These structures are 2-dimensional and 3-dimensional because they can measure length, width, radius, and others. Okay, let's carry on. Now, I will describe the geometrical shapes that exist in the Surau An-Nur building. First, in this building, there is a window with a square shape. So, what is a square? The square is a rectangle that has 2 congruent adjacent sides. Okay, the next geometrical shape that exists in this building is a rectangle. A rectangle is a parallelogram that has right angles. Its diagonals are equal in length, and it bisect each other at the right angles. In the window, there is also a semicircle shape. A A semicircle is a closed two-dimensional shape when an arc of a side of a circle with an point on the diameter cuts a circle into two equal halves. Those halves are called a semicircle. A semicircle is not a polygon, since it has a curved edge. In the face of the building, there is a hexagon shape. A hexagon is a two-dimensional polygon that has 6 sides, 6 vertices, and 6 angles. It is a typical shape that we can find anywhere in real life, such as in a honeycomb and football. In this building, the object occurred as an irregular polygon. There is also a right triangle shape in this building. A right triangle shape is a sided closed shape that has one perpendicular side called the length or height of the triangle. Therefore, a right triangle is when the angle between a pair of sides is equal to 90 degrees. The three sides of right triangle are related to each other, and this relationship is explained by Pythagorean theorem. Last but not least, the last geometrical shapes that exist in this building is a right triangular prism. A right triangular prism is a three-dimensional geometrical shape and a pentahedron and has 9 distinct necks. A right triangular prism has its 3 rectangular sides. Also, the 2 triangular bases are parallel and congruent to each other. The rectangular or lateral faces are perpendicular to the triangular bases. Okay, now I will explain the geometrical concept of each shape. First, for square, let EFGH be the midpoint of AB, DC, AD, and BC respectively. Since ABCD is a square, the median bisect each other. AC and BD are the diagonal of the square. They are congruent and bisect each other. The diagonal and bisector intersect at point O. This square has a side of length 121 cm, and since the square has an equal measure of length, therefore all sides are 121 cm. With this measurement, we can calculate its perimeter and area. For calculating the perimeter of a square, we need to sum up all of the sides of the length, or we can just multiply the 121 cm by 4. And the perimeter is 484 cm. Meanwhile, for area, we can calculate it by using formula length times width, means 121 cm multiply 121 cm, and then it gives us the value of area is 14641 centimeters square. So the next is rectangle. Rectangle has a similar concept with a square. So in this rectangle, it has 2 sides of length 108 cm each and 2 sides of length 33 cm each. Area of rectangle with base of length B and altitude of length H is given by A equal to BH with area. So the perimeter of this rectangle is 282 cm. Meanwhile, for the area is 3,564 cm square, where we can get it by using the formula area equals to BH. Okay, next, the semicircle. The semicircle in the window has a diameter of 121 cm. With this, we can calculate the circumference and area of the semicircle by dividing the value with 2. The circumference is given by C equals to pi over D over 2, where pi is the ratio between circumference and the diameter of the length. The circumference of a semicircle is also given by C equals to 2 pi r over 2, where r is the radius of the circle. All radii of a circle are congruent and all diameter of a circle are congruent. Radius is a half of the diameter. The area of semicircle is also given by area equals to pi r squared over 2. This is because the shape is semicircle, so we need to divide it by 2. So the circumference of this semicircle is 190 cm. We will get this by using the C equals to pi d over 2 formula. Meanwhile, for the area, we will get the value of 5,750 cm square. And to get this value, we will use A equals to pi r squared over 2.
Our next geometrical shape is hexagon. Hexagon is a closed two-dimensional polygon with 6 sides. The hexagon shape of this fence has 2 sides of length 20 cm each and 4 sides of length 10 cm each. With this measurement, we can calculate its sum of interior angles and perimeter. The sum of the measure of the interior angles of a hexagon fence with 6 sides, where n is greater than 2, is given by the formula S equal to n minus 2 multiplied with 180 degrees, such that S equal to 6 minus 2 multiplied with 180, and we will get 720 degrees. The perimeter of a hexagon is the sum of the length of its all sides, such that perimeter of hexagon is equal to 20 cm plus 10 cm plus 10 cm plus 20 cm plus 10 cm plus 10 cm, and finally the final answer is equal to 80 cm. The next geometrical shape is right angle triangle. This right angle triangle has legs of length 330 cm and 62 cm respectively. With this measurement, we can calculate its perimeter and area. The perimeter of a right angle triangle is the sum of lengths of its all sides, such that 330 cm plus 62 cm plus 335.77 cm, and finally we will get the perimeter is 727.77 cm. The area of this right angle triangle is given by a formula A equal to 1.5 AB, such that A equal to 1.5 330 cm multiplied with 62 cm, and we will get 10,230 cm square. The last geometrical shape that we investigate is a right triangular prism. This is a right triangular prism with an altitude of 43 cm and a right triangular base that has legs of length 330 cm and 62 cm respectively. With these measurements, we can calculate its total area and volume. First of all, we calculate its perimeter, and we will get the value 727.77 cm. Next, we calculate the lateral area L of a prism is given by the formula L equal to HP, with h is the altitude and p is the perimeter of the base. So by substituting everything into this equation, we will get the lateral area is equal to 31,294.11 cm square. Since the base is a right angle triangle, we can calculate the base area by using the formula B equal to 1.5 AB. So by substituting all the information into this formula, we will get the base area is equal to 10,230 cm square. Finally, we will calculate the total area of the prism is given by formula A equal to L plus 2B, where L is the total lateral face area and B is the total base area. By using the formula, we will just substitute everything into the formula. We will get the total area is equal to 51,754.11 cm square. To calculate the volume of a right triangular prism, we use the formula V equal to BH, where B is the base area and h is the length of the altitude. For the base area, we will use the same values as we have previously already calculated it just now. So, we substitute everything into this formula and we will get the volume of the right triangular prism is equal to 439,890 cm cubed. Transformation is a process to change the original object in size, position and orientation. Based on these two figures, we can see that the motif of the geometrical shape produced is from the combination of square shape and semicircle shape. By the existence of a line of reflection shown in the above figure, we can detect the use of the reflection transformation formed on the motif of the Surau An-Nur windows. According to this figure, we can see that the motif is a hexagon shape. A combination of a hexagonal motif creates a pattern. The hexagonal undergoes rotation transformation to form the pattern of the fans of the Surau An-Nur. The hexagonal motif in the figure above rotates 90 degrees at the point of the rotation clockwise.
Okay, so hello and selamat sejahtera. My name is Mary Mishai Umbaga and I will explain to you about the summary for this assignment. So, in summary, the building that we chose is located at Sultan Abdul Jalil Shah campus next to the gymnasium, and across the street is Bangunan SKTM and tennis court, which is known as Surau An-Nur. Kestevan, a well-known architect from the Federal Malay States, designed the structure of this Surau An-Nur. So, the Surau An-Nur is used for students, lecturers, and visitors to do their prayers while they're in campus. By strategically located at the corner of the road next to the gymnasium, students, visitors, and lecturers can find this Surau An-Nur easily. By the building that we chose, we can detect many shapes, such as rectangle, square, semicircle, hexagon, right angle triangle, and right triangular prism. All the shapes in this building structure have different measurements that involve angles, perimeters, volume, lengths, and others. So for the conclusion of our assignment, during conducting our assignment, our group worked as a team to find the structure in each building. We decided to choose Surau An-Nur as our building as it has many shapes such as square, rectangle, semicircle, hexagon, right angle triangle, and right triangular prism. So we also gain valuable insights into these practical applications of geometry in real life situations by searching around the OOPSI. This whole experience has enhanced our problem solving skills by seeing through the geometric lens.